Our panel discussion will provide some insights into disruptive technologies impacting business today, additive manufacturing, the Internet of Things, and connecting people to data. And Jeremiah, would you like to introduce your panel?
I certainly would. Gentlemen, come up and take a seat, and we will get started. All right. We have Dr. Bluestein. Please sit down. He's from Stony Brook. And we also have Shawn, who's the director of CAD/CAM at Wichita State University. And we have Yves-Marie, who is also from in parking solutions, Parkeon. Welcome, gentlemen. We have 20 minutes for this panel, so let's get started. First, can you give us an introduction about what you do and about your passion project?
Quickly, I'm a professor of biomedical engineering dealing with cardiovascular sciences and cardiovascular devices, actually meaning cardiovascular engineering. So in that, all kinds of devices that support the heart and may help patients survive and extend the lifespan. And part of my collaboration with Dassault Systèmes involves the Living Heart project.
And there's an example we get to see later, right?
Yes.
So you're helping to save the world. Heart disease is the #1 cause of death in many countries. So very important work. Shawn, tell us about what you're working on.
Yeah, I'm the director of the CAD/CAM lab at Wichita State University, NIAR, which is the National Institute for Aviation Research. We have several labs there, including additive manufacturing, robotics, virtual reality, reverse engineering, and we're very strong in the composite world, especially in A&D. We do everything from the coupon level testing all the way up to full-scale structural tests.
Good. Yves-Marie, welcome. You know, I struggle with parking all the time. I never know where spots are. I'm always going to worry I'm going to get a ticket. I don't even know if there's going to be an open space. What are you working on to make the world a better place?
Thanks for the question. We are Parkeon is a worldwide leader in the on-street parking industry, so we have some solution to help drivers to find a free parking spot, like Pass to Park. And we have a lot of solutions, like a back office to help cities to improve how a city is working, because they are able to modelize where are the residents, workers, all these things.
Great. Thank you. Danny, to kick things off, we just talked about heart disease as one of the reason causes for death. What is the goal of your project, The Living Heart?
Well, basically, people may not realize it, but nowadays was a kind of new solution for patients who wouldn't be able to survive open heart surgery in order to replace the diseased valves, and basically they would have died. So for the last several years, there's something that is called transcatheter aortic valve replacement, which is basically implanting a replacement valve without the need for surgery. So you may raise an eyebrow how something like that is possible. So the idea is to stent the valve, the same way that we use stents in occluded arteries, technology that exists for over 20, almost 30 years now, and became very successful. So nowadays we have this new type of technology where you crimp the valve into a stent and then deploy it over the diseased valve without removing the diseased valve, without opening the chest of the patient, etc. Now, the Living Heart project has some beautiful features to it. And basically, you have a virtual reality in silico model of a pumping heart, the electromechanical behavior of the heart. We actually use this in order to test designs of such transcatheter aortic valves in order to see how the device will react when we're going to deploy it under the conditions where it's coupled with a pumping heart in the virtual world. And the beauty of it is that in the virtual world, you can do a lot of design optimization to actually test to see whether it's going to work or not. And here we actually also segueing to another aspect of what we do, that We can then use, for example, 3D printing in order to fabricate prototypes and then test them and see how they work. So the beauty of this approach is that we now can kind of couple our device with pumping heart. Now, this is a collaborative project, so there's a lot of, you could say, data sharing, crowd sharing, similar concept to what you've discussed earlier. And in that, because this is actually collaborative effort of many, many researchers and scientists and technologists, we can help each other to achieve a much better solution that indeed will benefit the patients.
Thank you. So speaking of 3D printing, Shawn, what are some of the things you're working on? What are you seeing out there?
Additive manufacturing obviously has gotten a lot of steam lately. It's been around for a very long time, much longer than people probably thought it has been. A lot of press been going on with the, building a car out of additive manufacturing, which is definitely out there now. The thing they don't show you is, the amount of finishing work that has to be done, all the electrical that still has to be ran, the framing, the tires and such. But we're basically what you're working on with additive manufacturing is we're trying to get away from those small machines. The OEMs, they have these small machines that are relatively small, trying to get into large-scale building. So one area we're working on is with robotics, using multiple robotics and creating an additive manufacturing cell that is over 29 feet long, that we can actually build full items inside there using additive technologies. Also utilizing the robot's degrees of freedom, so we're not stuck to just a gantry type system where you're printing X, Y, and Z layers. So we can actually control layers and control orientations of our layers. So that's what we're working on mostly. There's still obviously a lot of investigation going into metallics, metallic additive manufacturing. You've recently heard that some parts have been put on some engines on airplanes. We're still quite a ways away from getting FAA certification to put a structural part on an aircraft. There's still a lot of controls that are out there. Materials aren't controlled enough. The machines aren't controlled enough. So there's still a ways to go, but it's progressing very fast.
So what's the change to the ecosystem? So if 3D printing arises, are we going to print things, or additive manufacturing, are we going to make things on demand in local spots? Does it change the supply chain?
Yeah, I think there's some visionaries out there that have a concept that we call a micro factory. Basically, I always refer to it as like a Kinko's, where you go to Kinko's now if you want a copy of something or something printed, you can go there. It'll be no different. You'll have these micro factories that you can go, take your designs, either submit the file through the web or actually go there in person, get a quote, and that part can be produced for you. So, yeah.
Big change. Yeah, please jump in. Then we'll go to Yves-Marie.
On that, because we are using a similar concept in this design of heart valves, because nowadays medicine is moving to what's called patient-based or precision medicine. And we would like to design these valves to fit the best for an individual, specific patient. And in that, again, this virtual domain and the fact that we're using medical images to reconstruct the geometry and then test it in this in silico virtual domain enabled us to design something that we term conformal valve, that conforms to the specific patient.
That's right. So, yeah.
Which is done in
personalized.
For implants, prosthetics, reverse engineering off of a CT scan, building the bone structure, building the customized implant, printing that implant, using different materials that adapt to your body better. Those are all things that are going on.
So speaking of personalized data, let's go back to Yves-Marie. How are you using data for parking solutions in supply chain?
Yes, we are the worldwide leader, as I said, so we have 200 parking meters on the ground, and 100,000 parking meters are connected to our data centers. So we are gathering a lot of information. One of our goals is to provide a dashboard to the cities, because we are selling to the cities. So New York City, Las Vegas, or Austin are able to manage asset revenues and maintenance. But we want to go far away from that, because with a parking ticket, you can know where your residents are, where the workers are, where you are doing shopping, when, all these things. So our idea is really to help cities to better modelize this individual information into something that could make sense for a city, in order to optimize parking rates or to develop shops, or they can manage that through the parking.
Excellent. So guys, going back to designing products, personalized products, how does that impact all of the designers and product managers out here if everything's personalized? What does that look like?
Well, in terms of additive, it's a relearning process. Everyone's been used to you design for manufacturability, and you're kind of constrained to your subtractive manufacturing technologies that you basically grew up with. We're seeing college students now, even high school students, that don't have those limitations, and they design completely differently than what you'd find someone in the aircraft field right now designing. And really, you kind of need to mix those two together. We're still not to the point where anything you can design, you can send to an additive manufacturing machine, hit a button and print, and it works. There's still some techniques to that. There's still things you got to live and learn from. But the way you think and the way you design is definitely different, and it's going to require some change in training for existing workforce. And the current workforce still needs to learn some idea that you still have some confines, but not nearly the number that we used to have.
Okay. Doctor, do you have anything to add to that?
Yeah, besides this direction that will really transform medicine of personalized precision medicine, there's also a kind of a paradigm shift that involves several of the aspects that we've already discussed here. And the fact, historical fact, is that most medical devices were designed with not too much afterthought, but just to solve a problem. And sometimes they worked wonderfully, sometimes they worked with many problems, sometimes they were catastrophic. And in that, if we adopt the approach that is almost traditional in something like aerospace engineering, and I show this kind of a background, you don't design a prototype, take off, and crash and burn. You actually test it. You go through all kind of wind tunnel testing. You have all kind of ways to guarantee that by the time you build your prototype and take off, you won't crash. And unfortunately, in medicine, this wasn't the case. In the last 2 decades, there was this paradigm change. And now with projects like the Living Heart project and similar convergence of ideas, it is possible to design medical devices that will be both personalized and also optimized. So by the time you actually use them in a patient, implant them, you'll get much better clinical outcomes. And it will also most likely save a lot of money during the research and development phase and also during clinical trials. And in that, we may even in the future forgo animal experiments that are now required in order to get approval for many such devices.
That's interesting. So thinking about personalized products, what does a personalized parking experience look like in the future? How will my life be better in the future of parking?
To simplify your life, we have 2 offers. You can pay, of course, your parking using your mobile, but it's not so complicated. But one of our main app, it's called Pass to Park. It helps you to find a parking spot. So when you need to park your car, you just have to call Pass to Park. And in a lot of cities, we're going to find a solution, a parking garage or a parking spot. So it's mainly deployed in France, in Paris, Bordeaux, or Toulouse, and we started in the US with Fort Worth, Austin, Las Vegas, or Denver. So we are trying to work on the real requirement of our end users because, of course, basically we are a parking better provider, so we've done a mobile parking payment because it's the same thing. But then we've asked what is the real need of our users. And you don't need to pay for your parking, but right. You need to find first a parking spot. So that's why we've done this app. And for now, we have 40,000 users.
What cities are you in? What cities are you in?
In France, it's Paris on all cities around, Toulouse, Lille, Lyon, Marseille, Cannes, all these cities.
Yeah, Paris needs help with traffic, so.
Yes, it's very complicated.
Yes, it
You
is.
should consider going to universities where it's hard to park too.
When are you arriving to Manhattan, by any chance?
So you have an actual market here. I mean, it's interesting when you think about population for all three of you gentlemen. So when my father was born, there was 2 billion people on this planet. When I was born, there's 4 billion. Today, there's 7 billion people. When I retire, there's going to be 9 billion. And when I die of a natural age, maybe I'll live longer with your heart solutions, is there will be 10 billion people on this planet. 2 to 10 billion in 2 lifespans. Right? Really, these disruptive technologies you guys are working on are really important. So painting that vision up to 2050 that I just talked about, this population growth, this impacts all three of us. Tell us what the world looks like in 2050, and we'll just go down the line and conclude our event.
Well, of course, extending the lifespan was always a kind of common goal, regardless of some forces that may consider otherwise. But regardless, always there should be a balance between extension of our lifespan and also the quality of life that we're living, and at the same time, some stability in the equation, the scale of the globe in general. So in that, of course, it could be that population growth should not necessarily be the same as today, and in that also achieve kind of balance. In physiology, it's called homeostasis. We should, I think, aspire for such homeostasis in the growth of population in the world.
Thank you, Doctor.
Well, as our materials go farther and farther and we develop ways to simulate those, obviously using a lot of products of Dassault Systèmes, the Biovia and the Simulia and things, be able to work systems out. What you're going to find I foresee, is you're going to find factories that are no longer a car manufacturer or a furniture maker or anything like that. You're going to find a factory that can do a variety of things. You're going to have machines that can just print. One day you could build furniture, one day you could build an automobile, one day you can build a drone with that type of technology. And of course, as you see, obviously in the military aspects and defense aspects, instead of sending inventories of parts somewhere, you're going to send machines with data. And then if you need a part, you'll just print the part that you need, right? And so that's what you're going to be seeing.
Just like those Coke machines that produce every type of flavor,
freestyle,
right?
yeah.
And there's no supply chain or bottling done. It's done there, right on the spot.
You're going to bring mixed materials, customized material.
So that actually impacts global shipping too, right? Because you have less materials and you have less inventory as well, right? So there's significant sustainability impacts as well.
Sure.
2050, what do cities and traffic look like, Yves?
Not so easy.
What's
It's
that?
recorded. It's recorded. So it's always dangerous to predict the future when you are recorded. But about mobility, yes, we have some ideas, and it have been discussed a few minutes ago. It's to integrate emotion and quality. For example, when you want to take a bus, you need to know, okay, the bus will arrive in 4 minutes. It's quantitative information. It's not a qualitative information. I want to know if the bus is full or not, because maybe I will wait the next one if I will have a seat on the next one.
Multimodal
so
as well.
it's more emotion. It's my comfort. Same for if I want to take a car, if I will be in the traffic jam or not. For me, it's a comfort. So we have to integrate all these things in the application, and it's not so easy because it's not just accountability. Okay, you have a space or not. It's comfort. So it's more about the emotions, all these things. So it will be very complicated to learn, but it's something we have to do to simplify the life of our end users.
Great. And you have exhibits in the other room to share? The Living Heart exhibit?
Not myself, but...
So will you gentlemen be around to meet some of the audience afterwards?
Yeah.
Okay.
Definitely.
Please give our panelists a warm thank you. Applause. Thank you.